All right, we are doing matrix row operations. We are operating on each row, doing some sort of operation, multiply or combining. So basically what's happening here, this is the elimination method. It's like the elimination method, elimination method, elimination method. And it's also like a distribution of a multiplying like by a number on both sides. So when you multiply a number on both sides, you distribute it throughout. So basically that's what's happening here. We have that 9. It's kind of like a scalar. We're going to be multiplying that whole row 3 by 9. That's what that means. And then we're replacing it with row 3. So elimination method is when you combine two rows, either you're adding or subtracting the rows together. That's the elimination method. That's how it's like. And then we have that multiplier that affects the entire row. So when you're dealing with these operations, make sure that you remind yourself it's a row operation, not a column. Only row operations here. So what this is saying is that the third row is being multiplied by 9. So the third row, this row down here, has a 9 that's being multiplied to it. Basically, it's distributing to each of these coefficients or constants. So it's distributing to each one. And then that says replace. So that one is replace, R-E-P-L-A-C-E. Replace it on row 3. So all that really means is a distribution of 9 onto row 3. Everything else remains the same. Let's see how we did. So we got a -5, -7, 8, 5. There's no change to row 1. Only row 3 is changing. Row 2, no change. 1, 2, -3, and 2, no change there. And then here's our change. That everything in row 3 got multiplied by 9. Everything in row 3 got multiplied by 9. So 9 times 1 is 9. 0 times 9 is 0. 9 times 0 is 0. And 9 times -1 is -9. Let's do one more. Otra vez. We are doing matrix operations. Matrix row operations, but they're operations on a matrix. We always do it by row, so they're just kind of being redundant here. Row 2 and row 3 are switched. So there's our switch sign. So that's a switch, S-W-I-T-C-H. That's a switch sign, so I switch row 2 and row 3. So if you think about a system of equations, it doesn't matter which one's on top and which one's on bottom. And that's basically what we have here. We have a system of 3 equations, 3 unknowns, and we are just switching row 2 and row 3. So row 1 is unaffected, -10, -10, 2, -8, and 1. And then these are flipped. So you got this. When you're doing row operations, matrix row operations is one of the few times where you kind of have to do this stuff in your head. Otherwise, you're writing it over and over and over again. So try to visualize what's happening here, and then you just let it roll out as you write it in. So row 2 and row 3 are switched. So row 3 is now where row 2 is. So these are all the row 3 entries. 1, 4, -6, and 2. Now, when I'm writing it or when I'm typing it in, all I do is I focus on the third row and I just type it into the second row. That kind of keeps my mind from being confused. If I try to look at the whole thing at once and do it at once, it oftentimes gets a little bit blurry to me, like which one's which. So I just focus on one at a time and put it where it needs to go. Same thing here. Everything in row 2 is now in row 3. So I'm just looking at row 2. It's a 3. It's a -2. It's a 2. And it's a 2.